So in this video, we're going to be going over rationalizing substitutions. This is another type of U substitution. It just falls underneath the topic of U substitution. But in rationalizing substitution, we're going to be using the letter T. So we're going to be using the letter T instead of the letter U to basically help us integrate. So it's usually integrals of the form like this, where R is the rational expression and X and the root. So whenever you see a root, think of like rationalizing substitutions and trying to substitute whatever that root is with the letter T, and we get it in terms of T. So when we're gonna be setting, so right here we're gonna be setting whatever the root in the problem is to T, and then just like how in definite U substitution we have to change the bounds if there are any bounds, we have to make sure that whatever the X is, whatever the dx is, we change it into terms of T. In terms of T, and we should get basically a rational function that we can integrate. So pt over qt. So this just represents a rational function, pt over qt, but it's in terms of t. And that's what we want when we're doing rationalizing substitutions. So let's actually just do let's just do an example. So the example is we want to integrate radical x minus 4 over x dx. And now how would you solve this now? So previously we said that we want to set whatever the root is, whatever radical root we have, we want to set it to T. So let's do that. So let's say T is equal to radical x minus 4. That's the only radical I see here. So we know T is equal to radical x minus 4. Now, we also see there's an x on the bottom. So in order to actually make this in terms of T, we need to solve for x as well. So we have something we can substitute for x. So let's solve for x. So all we have to do is just square both sides to get rid of the root. We get T squared x minus 4, add 4, add 4. We get T squared plus 4 is equal to x. Right? So we have x right here. We can substitute that for x. We have T right there. And then once we get to this point, once we get to T squared plus 4 is equal to x. So let me actually erase this part. And right there. We also need dx, right? We need dx. We need something for dx. So in order to find dx, all we have to do is just take the derivative of this, right? And the derivative of that is just 2t dt equals to dx. That's it. So now that we have all the components we need, we can actually start writing the integral in terms of t. So this is the integral sign. We know t is going to be radical x minus 4. We know x is going to be t squared plus 4, right, because we solved for that. And we know dx is going to be 2t dt. So wait, for dx, it says we need 2t dt. We already have a t right here. All we really need is to add a 2. So what we're gonna do is move this t. So we're leaving a 1 right here. We're gonna move this t right here, right? And dt. So this is where dx was. This is where dx was, right? But we're gonna substitute it for 2t dt, and we're just gonna write the t right here. We're just gonna write it there, right? Because we need it. And since we added a 2, you have to put a 1/2 on the outside. So in the final integral, final solution, the 1/2s cancel, right? Since we added a 2, at the end, this 1/2 will cancel that 2. So we can continue with the expression now. So it's 1/2 1 over t squared plus 4 2t dt Actually, wait. I think I made a small mistake. So we still need to add that 2t dt. We still need to add that 2t dt. So what we're gonna do? Let's see. So let's continue. Let's continue doing what we were doing first. So we substituted, right? T squared plus 4 for x, and then dx. Let's just say dx is 2t dt. Let's just say that. We're not gonna add anything on the outside. We're just gonna substitute what we found, right? So 2t dt. Now, once we get to this point, we can simplify a little, and we get 2 squared, t squared, because there's a t here, there's a t here. And then we can pull this constant out by the properties of definite integrals. 2 comes out, and t squared o plus 4 dt. So we're left with that. Now that we're left with that, at this point, we have a rational expression, right? We have a rational expression. So what was the definition saying? It says once you set t equal to whatever that the root is, we're gonna end up with a rational function which we can easily integrate. So what we're gonna do is there's 2 methods we could do. We could divide t squared by t squared plus 4, or we could do a little trick method where we add a plus 4 minus 4 and then split the integral. So I'm gonna do the trick method because it's a lot easier. So this is what I'm saying: t squared plus 4, t squared minus 4, right? Since this is just gonna cancel and give us that, we could rewrite it a little to help us split the integral, and we get t squared plus 4 on the bottom. So this is what we get, right? Now what we can do is split this integral, right? We can split this integral with this. This could be one of the integrals, and this could be one of the integrals. So let's rewrite that again. 2. So this 2 is going to be on the outside, and we're splitting the integrals. So let's make parentheses. So t squared plus 4 over t squared plus 4 dt minus integral 4 over t squared plus 4 dt. So you see, that just helped us split it into 2 different integrals, and now we can solve from here, right? So we know right here, this integral, this is just the integral of 1, because the t squared plus 4 divided by t squared or plus 4 is just 1. So this is going to be 1, right? And over here, in the second integral, we can use the integral table to help us to actually find the integral. So when you look at the integral table, this can be rewritten so that we can get the integral of 1 over a, I mean the result of 1 over a tangent inverse x over a, right? So let's rewrite this a little again. So we get 1 dt, right, minus, so we pull out this 4 by the constant rule. We get 4, we get 1 over t squared plus 4 dt, and this could be rewritten, right? This could be rewritten, and so let's rewrite it. So this could be 2 squared, and we know that whenever we see something like 1 over a squared plus actually 1 over x squared plus a squared dx, right? Whenever we see something like this, the integral is going to be this. This is the general formula. So our integral right here. So let's integrate now. Now that we know what our integrals are supposed to be, let's integrate. So integral of 1 dt is just t. Integral of this entire thing right here is gonna be, we said 1 over a, right? So a in this case is 2. We said a is 2 in this case, and then the x part is just t. So 1/2 tan inverse, and we know it's x over a, so it's going to be t over, let's see, t over 2. So that's what we get so far. So now we can simplify a little. So 2 outside, t minus, so we distribute this, 4 to 1/2, we get 2, we get 2 tan inverse t over 2. So yeah, I'm just rechecking all my answers. Alright, so this is what we get so far. So now we have to switch back to x. Before we switch back to x, let's distribute this 2 as well, right? We cancel this 2 and this 2, and we get 2t minus tan inverse t over 2. So 2t tan inverse t over 2. Alright, so this is what we get so far, right? Now we have to switch all of this back to x in terms of x. So we know for x, we substituted in right here, t squared plus 4, right? T squared plus 4. Actually, no, for t. So we need to go from we need to go from t to x, right? T to x, and we substituted radical x minus 4 for t. So we use radical x minus 4. So you have to use t is equal to radical x minus 4. So let's do that. Let's switch back to x. Alright, let me just add equal signs here. This is just continuation. So now we switch back to x. And so t is radical x minus 4, right? X minus 2 times radical x minus 4 minus tan inverse radical x minus 4 over 2. And then this is an indefinite integral, so plus c. And this is our final integral.